Good day, viewers all over the world. I want to welcome you to class today. Today we shall be looking at a topic titled Solution to System of Linear Equations. Once again, I want to appreciate every one of you that have subscribed to my YouTube channel and to every one of you that have been sharing my YouTube videos across the globe. God bless you. The essence of this channel is to share knowledge in key topics in mathematics and statistics across the globe. And as you take part in doing this, God will bless you. Please, once again, try as much as possible to subscribe to my YouTube channel. The channel is Dr. Chris Isekaibe. Share my videos across your social media platforms and like my videos, and as you do, God will bless you. Once again, I welcome you to today's class. My name is Dr. Chris Isekaibe. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I own a doctorate degree in mathematics with distinction. I also hold a master's degree in mathematics and a bachelor degree in statistics. I am a specialist in numerical analysis, data analysis and modeling, statistical computing, and scientific computing. Why not, if you are an AI firm, you need the services of mathematicians or statisticians, I will be glad to be part of those that will be working with you as a team. And also, if you are a research institute, you do a lot of research, I can be part of your statistical analysis, I can be part of your numerical analysis across the globe. I work in Nigeria and I live in Nigeria. I speak English fluently and I write English fluently. Once again, my contacts are +234 8033021903. This one is for call and WhatsApp. Then the second one is +234 7066297535. This one is for call only. While my email address is chrisdavid2015@gmail.com. I have scholarly publications at national and international level, and I've also presented papers in renowned conferences within Nigeria and outside Nigeria. And I've also written books in statistics and mathematics, numerical analysis, and applied statistics for business, sciences, and engineering. I will be looking forward to hearing from you so that we can be part of what you are doing. Once again, let us go straight to the business of the day. Permit me to claim what we have here on the board. Today we shall be looking at solution to system of linear equations. When we talk about a system of linear equation, this is the general format. The general format of the system of linear equations. The system can be a 2x2 system, it can be a 5x5 system, it can be a 3x3 system. Now, there are various methods of solving a system of linear equation. So a method of solution can either be directive, it can either be a direct method or an iterative method. So methods of solution. So we have two types of methods generally. Number one is the direct method. Direct methods. Then number two, we have the iterative methods. The direct methods, for instance, we can talk about are the matrix inversion method, the Cramer's rule, we have the Gaussian elimination method, and so on and so forth. Then for the iterative method, methods, we have the Jacobi and we have the Gauss-Seidel. These are the two iterative methods that we shall be considering. So we shall be taking each of these methods one after the other. We shall be starting with the direct methods. And today we shall be looking at the matrix inversion method. Permit me to clean this part. We shall be looking at the matrix inversion method. The matrix inversion method. We shall be looking at the matrix inversion method. This is one of the direct methods used for solving a system of linear equation. This particular system of linear equation can be put in matrix form, in this form: A x is equal to b. Our A here is a square matrix. Our x here is a vector, a column vector, while our b here is a column vector. So we are going to have that this, our matrix A will now be A11. You will bring out the coefficient of the x. You have A11, A12 down to A1n. You have your A21, A22 down to A2n, down to AN1, AN2 down to ANN. Then you have it like this. This is the matrix A. Then our x, which is the unknown, is a column vector, will be x1, x2 down to xn. Our x is a column vector. Then our b is the right hand side. It will be b1, b2 down to bn. So this will now be our right hand side. So this is the matrix format of the system of linear equations. That is how it is done. It is the matrix format of the system of linear equation. So if you are able to do this, if you look at this, then the unknown is the value for x. X here is the unknown. Our A is a non-singular matrix. A non-singular matrix is a matrix whose determinant is not equal to 0. So our A is a non-singular matrix. That means the determinant of A is not equal to 0. That is what our A is. And of course, getting the value for x, we are going to, in matrices, there is nothing like division of matrices. If it is ordinary mathematics, now you are going to have A inverse A. You multiply both sides of this equation by A inverse. A inverse AX is equal to A inverse B. So now, but A inverse A is equal to the identity matrix. So you are going to have the identity matrix multiplied by x, which is the unknown, will now be equal to A inverse A B. So the identity matrix is like 1 multiplying by x, it will now be x, will now be equal to A inverse B. So we are now, that is the formula we are now going to use for the matrix inversion method. So our vector x, our column vector x, will now be equal to the inverse of A multiplied by the right hand side B. So that means this particular method involves the calculation of the inverse of the square matrix A. A is a square matrix and it must be a non-singular matrix. A non-singular matrix is a matrix whose determinant must not be equal to 0. The value, it can be positive, it can be negative, but it must not be equal to 0. So now we are going to look at steps for calculating the inverse of a matrix. Steps for calculating the inverse of a matrix, since we are using the matrix inversion method. we are using the matrix inversion, so we will need to calculate the inverse. So what we are looking at today is the matrix inversion method. So now, steps for calculating the inverse of matrix A. So A is a square matrix. So what are the steps? Step one, compute the determinant of A. Compute the determinant of A. A determinant is a value that describes a matrix. Determinant of A can be written as determinant of A or A in absolute. That's how we write the determinant of A. Then, and of course, the determinant of A must be strictly greater than 0. That means the matrix must be a non-singular matrix. If you calculate the determinant of A and the determinant of A is 0, then you cannot use the matrix inversion method to solve the problem. Step 2, calculate the matrix of cofactors C. Calculate the matrix of cofactors C. So C, capital letter C. Then step 3, you have to find the adjoint of C. Find the adjoint of C, or the adjoint of matrix A, which is equal to C transpose. So you transpose the matrix of cofactors to get the adjoint of A. Then the last step is just 4 steps. The last step, which is step 4, you get the inverse of A, or you can say multiply the adjoint of A by 1 all over determinant of A to get the inverse of A. To get A inverse. This is how A inverse is written. So you have to multiply the adjoint of A by 1 all over the determinant of A to get the inverse of A. And when the inverse is gotten, of course, you can solve the particular problem. So these are the steps for getting. Now let us take an example. Solve the system of linear equation using the matrix inversion method. This is the problem. You have 3x1 plus 3x2 plus 5x3 is equal to 24. Then the next one is 3x1 plus 5x2 plus 9x3 is equal to 40. Then the third one is 5x1 plus 9x2 plus 17x3 is equal to 74. So this is a 3 by 3 system. So you are going to use the matrix inversion method to solve this problem. Permit me to clean these steps for getting the determinant or the inverse of a square matrix. So this is the problem. This is the problem. It's a 3 by 3 system. So from here, we can put this particular problem in the matrix approach. This is the matrix approach. A is a square matrix multiplied by the vector, which is the unknown, is equal to B, which is the right hand side. B is a column vector, X is a column vector, A is a square matrix. When you have two bars under a capital letter, it's a matrix having rows and columns. When you have a capital letter having one bar, it's talking about a vector. It's either it is a row vector or a column vector. So now, from this problem, look at our A. If we put this in matrix form, our A will now be 3. We are taking the coefficients. The next one is 3. The next one is 5. Therefore, the second equation is 3. The next one is 5. The next one is 9. Then for the third equation is 5. Then the next one is 9. The next one is 17. Then this is A. This is matrix A. Then our X will be the unknown x1, x2, and x3. This is a column vector. Then our right hand side is the B. That will be 24, 40, 24, 40, and the next one 74. So this is the right hand side. So this will be our A, and this will be our X, and this will be our B. B is a vector, X is a vector. So that is the first thing you do. You decompose the system of linear equation into the matrix format. You put it in the matrix format, then from there you now begin to calculate the value for the inverse. So remember, for us to get our X alone, from what we have said, X will be equal to A inverse B. So like in ordinary mathematics, in algebra, for instance, if I have 2x is equal to 6 in ordinary algebra, I will now come, for me to get my X, I will say X is equal to 6 over 2 is equal to 3. This one is good to go for algebra, but not in matrices. If in matrix you have this form, if you have AX is equal to B, and you now see your X will be equal to B all over A, you are wrong. In matrices, there is no division of matrices. We have addition of matrices, we have multiplication of matrices, we have subtraction of matrices, but there is nothing like division of matrices. What we have is inverse. So the A here on the right hand side will move, and the A here on the left hand side will move to the right hand side. You now have your X will now be equal to the A inverse multiplying by B. This one is good to go, but this one is wrong. So please take note of that. So now we have been able to decompose the system of linear equation into the matrix format. The next thing we need to do, this is our matrix A, it's a square matrix. The system is a 3 by 3 system. Like as I said, you can have a 7 by 7 system, an 8 by 8 system, a 9 by 9 system, a 10 by 10 system. But one thing is sure, you make sure that you have the correct answers. Now let us go to calculate the inverse of A. The first step is to calculate the determinant of A. So the determinant of A, please follow me. As I do it, there is what we call the matrix of signs. Matrix of signs. Permit me to clean this part. The matrix of signs. Matrix of signs. So you have, since this is a 3 by 3 matrix, you have plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is the matrix of signs for a 3 by 3 system. It will help us to get the matrix of cofactors. First of all, let's go ahead and get the determinant. The first value here is 3. I'll bring out, if you are considering this 3, this column goes, this row goes, you have 5, you have 9, you have 9, you have 17. Then the second sign here is minus. So this will be minus 3. You come here, this row goes, this column goes, you have 3, 9, 3, 9, 517, 517, then plus the last one is 5, then this one, this column goes, this row goes, you have 3, 5, 5, 9, 3, 5, and 5, 9. That's what you have. So now our determinant of A will be equal to 3 into 5 multiplied by 17 is 85. 9 by 9 is 81. Then minus 3 into 3 times 17. 3 times 17 is 51. 5 times 9 is 45 minus 45. Then plus 5 into 9 times 3 is 27. Minus 5 times 5 is 25. So you have that. So permit me to come here. Our determinant of A will be equal to 3 into 85 minus 81 is 4. Then minus 3 into 51 minus 45 is 6. Then plus 5 into 27 minus 25 is 2. So our determinant of A will be equal to 12 minus 18 plus 10. And that will now give you the answer to be equal to 4. So take note of that. Our determinant of A is 4. Determinant of A is 4. So step 2, we want to calculate the matrix of cofactors. Please take note of this. You can see the steps we have used to get the determinant of A. Now we want to go ahead to calculate the cofactors. Permit me to clean this part so that we can calculate the matrix of cofactors. This matrix of signs will be very useful to us. Now let us go. Permit me to share this board into 2. For the first value that is 3, it is plus. So we are going to have, for 3, we are going to have plus, this one goes, so you have 5, 9, 9, 17. So that will be plus into this. 5 times 17 is 85. 9 times 9 is 81. So 85 minus 81, the answer will be plus 4. Then you come here again for this second 3. Of course, the sign here is minus. So this is minus into this row we go, this column we go to be 3, 3, 9, 5, 17. So it will be minus into 17 times 3 is 51. 5 times 9 is 45, minus 45. 51 minus 45 is 6, so this will be minus 6. That's how it goes. Then again, you come for the next one value there is 5. For this 5 here, so the sign here is plus. So we are not going to have this one goes, 3, 5, 5, 9. 3, 5, 5, 9. So this will be plus into 9 times 3 is 27. 5 times 5 is 25 minus 25. So 27 minus 25 is 2. So this will be plus 2. Then we come to this one. The next one is 3. For 3, of course, the sign here is minus. Then if the 3, this goes, we have 3, 5, 9, 17. 3, 5, 9, 17. So that will be minus into 17 times 3 is 51. 9 times 5 is 45. 51 minus 45 is 6. Because of the minus sign here, it will be minus 6. Then we go for the next one, which is 5. For 5, for this 5 here, this one goes, this one goes. You have 3, 5, 5, 17. And the sign is plus. You have 3, 5, 5, 17. 3, 5, 5, 17. So you come again, there's the plus sign outside, because for the 5 there, then 17 times 5 is 17 times 3 is 51. 17 times 3 is 51. 5 times 5 is 25. So the answer will be plus, so it will be equal to plus what? 51 minus 25 is 26. So is, okay, let me write it quickly. So this will be plus into 51 minus 25 is equals to plus 26. So the next one is for 9. For 9, you have a minus sign there. So minus this will go, this will go. You have 3, 3, 5, 9. You have 3, 3, 5, 9. So you now have 9 times 3 is 27. Of course, there is a minus sign outside. 27 minus 3 times 5 is 15. And 27 minus 15 is 12. So this will be minus 12. That's what you are going to have there. Then the next one you come here is for this 5. For 5, I hope you are taking note. For this 5 is plus. So if it's for this 5, this goes, you have 3, 5, 5, 9. 3, 5, 5, 9. Then you come, because it is plus, 9 times 3, 27. 5 times 5 minus 25. So this is plus 2. Then you come here again for plus 9. For 9, of course, it's a minus sign. You have minus. This goes, this particular column goes, this particular rows goes. You have 3, 3, 5, 9. 3, 3, 5, 9. So this will be equal to minus into 3 times 9 is 27. So this will be 27 minus 5 times 3, 15. So 27 minus 15 is 12. So because of the minus sign outside, it will be equal to minus 12. Then for the last one, which is 17, for 17, the sign here is plus. So you put your plus. Of course, this row goes, this column goes. You have 3, 3, 3, 5. You have 3, 3, 3, 5. So this will be equal to plus into 5 times 3 is 15. Minus 3 times 3 is 9. So you are going to have plus 6. That is what you are going to have for that. Now, permit me to write our matrix of cofactors. We have gotten it to the end. Permit me to clean this part of the board. So, our matrix of cofactors, which is C, putting all the cofactors together, our matrix of cofactors C will be equal to, we are starting from here, is, we went through the rows like that. So the first one is 4, just write 4. The next one is minus 6. The next one is 2. The next one is minus 6. The next one is plus 26. Then the next one is minus 12. Minus 12. Then the next one is plus 2. Then the next one is minus 12. Then the last one is 6. So this is a 3 by 3 matrix of cofactors. So you can see how we're able to get the cofactors. So at the end of the day, you can see that we are making progress. Please, once again, this is Dr. Chris Esekaibe, my channel, teaching mathematics core topics in mathematics and statistics. Today we are looking at solution to the system of linear equations. And please subscribe to my YouTube channel, Dr. Chris Isikaibe. Click on the bell button for notification so that anytime I upload a new video, you will be among those that will get a notification. Share my videos in your social media platform, like my videos, be part of those sharing knowledge across the globe. The key importance of this channel is to share knowledge across the globe. As you take part in doing it, God will bless you abundantly. So this is the matrix of signs that we have used to get the matrix of cofactors. So we have been able to get that. So permit me to clean this part of the board so that we can make good progress. So this is the second step that we just did, getting the matrix of cofactors. So step 3 says, step 1, we computed the determinant of A and we got the value to be 4. Step 2, we computed the matrix of cofactors, and that is what we just did. Now the step 2, we computed the matrix of cofactors. Step 3 is to compute the adjoint. This is the short form of writing it, the adjoint of A, which is the transpose of the matrix of cofactors. Now, if C is this, then our C transpose, what do we mean by transposing a matrix? It means turning a matrix 90 degrees, making the rows to become the columns. That is what it means. So now, we want to turn, this is the first column, we will make the first column to be the first row, make the second column to be, that's what it means by turning a matrix 90 degrees. This is 90 degrees, so the row becoming the column, that is what it means. The row becoming the column. So it's you are turning, making each row to become the column. So you are making it 90 degrees. So now, this is the first column, 4 minus 6 and 2. You make it the first row. So now 4 minus 6 and 2. This is the second column, make it the second row, minus 6, 26 minus 12. This is the third column, which is 2 minus 12 and 6. You make it the third row. This will be 2 minus 12 and 6. There is not something I noticed for this particular problem. You can see that even the matrix of cofactors, when you transpose it, is still getting the same matrix of cofactors. When you transpose it, look at it now. C transpose is the same thing as C for this particular problem. So this is a unique case. It doesn't happen like that all the time. When you transpose the matrix, at times you get a different matrix entirely. But for this particular case, which is unique, you will see that C transpose is now equal to C. Then the last step, which is step 4, says multiply the C transpose by 1 all over the determinant of A. So that is what we are going to do. So what is our C transpose? We are going to do it this way, by 1 all over the determinant of A. So what is our determinant of A? Our determinant of A is 4. Determinant of A is 4. Then you multiply it by this adjoint of A, which is 4 minus 6, 2 minus 6, 26 minus 12. Then you have 2 minus 12 and 6. So by the time you have this, you are going to have the adjoint of A. Let's call it the adjoint. Okay. You know, we are going to get the inverse of A to be equal to, we are going to have the inverse of A to be, that means you are dividing each element in this adjoint, which is the transpose of the matrix of cofactors, by 4. 4 divided by 4, you have 1. Minus 6 all over 4, you have minus 3 all over 2. 2 over 4, you have 1 all over 2. Minus 6 all over 4, you have minus 3 all over 2. 26 all over 4, you break it down, you have 13 all over 2. Minus 12 over 4, you have minus 3. Then you come again, 2 all over 4, you have 1 all over 2. Minus 12 over 4, you have minus 3. 6 all over 4 plus is 3 over 2. So this is now the inverse of A. This is the inverse of A. This is now the inverse of A. Now note that permit me to clean this top part. We are looking at the matrix inversion method. Permit me to clean this part. Note that also leave that. Let me clean this part too. Let me clean this part too. So you need to note that we are looking for X. Note that our X is equal to A inverse B. Our B is the right hand side. So our X, which is equal to X1, X2, X3, our X is the unknown, the vector of the unknown. We have 3 unknown, X1, X2, X3, will now be equal to our A inverse will be 1 minus 3 all over 2, 1 all over 2, minus 3 all over 2, 13 all over 2, minus 3, 1 all over 2, minus 3, 3 all over 2. So this is our matrix A, and our B is 24, remember, 40 and 74. That is what you have there. So we are going to carry out this simple multiplication. Permit me to clean this part. So we are gradually rounding up. Don't forget to click on the notification button to share my videos. Now, the next thing we have to do is to multiply. Of course, you know the rule for matrix multiplication. The row, taking the column. So now you have it like this. You have bracket of 1 times 24 plus the next one is minus 3 all over 2 times 40. This one times this then plus 1 all over 2 times 74. You cover the bracket. We are going to have it as this. Then the second one, this goes to with this. You have minus 3 all over 2 times 24 plus 13 all over 2, 13 all over 2 times 40 plus minus 3 times 74. That's what you have. Then for the third one, you have bracket 1 all over 2 times 24. Then plus the second one is minus 3 times 40 plus, then the last one is 3 over 2 times 74 plus 3 all over 2 times 74. You cover the bracket. Then it goes like this. So now that you have that, you are going to have your X, which is equal to X1, X2, X3, which is a vector, a column vector, to be equal to 1 times 24 is 24. 1 times 24 is 24 minus 3 over 2 times 40. This 2 here, 1, 2 in 40, 20. 3 times, minus 3 times 20 minus 60. Then 1 over 2 times 74 will be plus 37. Then the next one, minus 3 over 2 times 24, you are still going to have minus 3 over 2 times. So 2 here, 1, 2 in 24, 12. Minus 3 times 12 will be minus 36. Then the next one, 2 here, 1, 2 in 40 is 20. 13 by 20 is 260 plus 260. Then the next one, minus 3 times 74 will be minus 222. Minus 222. Then the third one, 1 over 2 times 24 will be 12. Then minus 3 times 40 will be minus 120. Then the last one, then 3 over 2 times 74 will give us 111. So when you carry out this, you are going to have 124 minus 60 plus 37, you will have 1. Minus 36 plus 260 minus 222, you are going to have 2. Then 12 minus 120, plus 12 plus 111. 12 minus 120 plus 111, you are going to have 3. So this is what you are going to have. So by implication, this implies that x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. That is what we have. So you can see that we have successfully solved the problem. Now remember, the problem is 3x1 plus 3x2 plus 5x3 is equal to 24. The second one is 3x1 plus 5x2 plus 9x3 is equal to 40. And the third one is 5x1 plus 9x2 plus 17x3 is equal to 74. Now let us cross-check. Let us cross-check. Our x1 by the matrix inversion method, x1 is 1, x2 is 2, and x3 is 3. Now let us cross-check. If x1 is 1, we are going to have 3 into 1 plus x2 is 2 plus 3 into 2 plus 5 into x3. What are we going to get? Then the second one is 3 into 1 plus 5 into x2, that is 5 into 2 plus 9 into x3 plus 9 into 3. What are we going to get? Then the last equation is 5 into x1, x1 is 1 plus 9 into x2, x2 is 2 plus 17 into x3. Well, x3 is 3. What are we going to get? If you put this in, 5 times 3 is 15. 3 times 2 is 6. 3 times 1, 3. When you add it together, you are going to get 24. The next one, 9 times 3 is 27. 27 plus 10, 37. That is 37 plus 3 will be 40. Then the last one, 17 by 3 is 51. 9 times 2 is 18 plus 18 plus 5, you are going to get 74. So we are good to go here, good to go here, good to go here. That means the particular problem is solved. That means the values for x1, x2, x3 is perfect. x1 is equal to 1, x2 is equal to 2, and x3 is equal to 3. And we have been able to cross-check with a system of equation, and we found out that the 3 values satisfy the three equations. So beloved, we have been able to use the matrix inversion method to solve this particular system of linear equation. You can see how simple the method is. It's a very simple method. It's a straightforward method. And then I believe you will be able to apply it in solving your problems. You'll be able to apply it in solving any problem, in solving any system of linear equation. It can be a 4x4 system, a 5x5 system. All you just need to do is to know how to calculate the inverse of that matrix, and you multiply by the right hand side, then you get the values for the unknowns, which is x. God bless you for listening to my class today. I believe you have learned. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. Click on the notification button, and so that anytime I upload a new video, you will have a notification. Share my videos in your social media platform. Share them in your Facebook, in your WhatsApp, Instagram, with whatever way you can share it, so that you can be part of those sharing knowledge. Do that and God will bless you. Once again, if you are an AI firm, you deal with artificial intelligence. I am an expert in mathematics, that is numerical analysis, data analysis, and modeling. I'm also an expert in statistical research and mathematical research, and also scientific computing. You can contact me so that I can be part of your team of mathematicians or statisticians doing great jobs across the globe. I'll be expecting to hear from you. My contacts were released at the beginning of the video, and you will see it at the description of this channel. You'll see my email address, my contacts there. I'll be waiting to hear from you so that I can partner with your team. God bless you. Enjoy the rest of the day. I'll be coming up with my next video in another method. I'll be coming up with another method for solving, another direct method for solving a system of linear equations. Today, it was the matrix inversion method that was used, which is a direct method. So we'll also consider another direct method in my next video. Thank you very much. God bless you. Have a great day. Bye.